We're going to graph sine of x. We're going to graph the sine function. So before we start, let's remember the unit circle. Think of this as the x-axis and the y-axis. This point is 1, 0. This point is 0, 1. This point is -1, 0. And this point is 0, -1. Now remember, your y values of each point represent sine. So this is your sine. And I'll go ahead and write the radians. This is 0 or 2 pi. Up here, do you guys remember what this is? Exactly, pi over 2. Here's what? Pi. And down here? Exactly. So guys, I'm going to go ahead and graph the sine function using what I know about the unit circle. Okay, so instead of using, you're used to when you graph, you put in numbers like 1, 2, 3, and 4. We're not going to do that. I'm going to put in values such as, this is 0. This is going to be my pi over 2. This is going to be pi. This is going to be 3 pi divided by 2. And this will be 2 pi. And remember, we're graphing the sine function, so I'm going to be paying attention to the y values. So guys, what is sine at 0? 0, so put a 0. What is sine at pi over 2? 1. So at pi over 2, your y value is 1. What is sine at pi over here? 0. Sine at pi over 2 is -1. So I'm going to be down here. And at 2 pi, sine is 0. So this is what my sine function looks like. Now, if I wanted to do another lap around the unit circle, it would follow that same pattern. You could just keep going around the circle. Okay? So it can go on forever. Now I can also go counterclockwise. So what if I did sine of -pi over 2? That means I went this way and I'm right here. What is sine at -pi over 2? -1. So that means at -pi over 2, you're here at -1. So guys, the pattern continues on the left side as well. So let's answer the questions. Amplitude means your midline. This is your midline. The distance from the midline to the highest point. What's the distance between the middle, the midline, and the highest point? 1. So your amplitude is 1. Another definition for amplitude is the midline to the lowest point, which is also 1. Okay? The period. That is how long it takes to complete one sine cycle. So we went from 0 to 2 pi. So your period is 0 to 2 pi. That's how long it took to create one cycle of sine. So your period is 2 pi. There is no phase shift. We didn't move left or right. Your domain will always be all real numbers, -infinity to infinity. Range is bottom to the top, so the very bottom is at -1, and the top is at 1. This is your relative maximum. The point is pi over 2, 1. That's your relative maximum. And your relative minimum is down here at 3 pi divided by 2, -1. That's your relative minimum. Okay, using your knowledge of the unit circle, you guys are going to now graph cosine, the cosine function. Ready, go. Try. All right, let's see if you got it. So I'm going to do 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so cosine at 0, look at my graph, my unit circle. What is it? 1. So at 0, I'm at 1. Cosine at pi over 2. Look at pi over 2 on the unit circle. Look at the x value. It's 0. So you're right here. Cosine of pi. Look at your unit circle. The x value is -1. So pi is at -1. Cosine of 3 pi over 2. Look at the unit circle. The x value is 0. So you should be back at 0. And then cosine at 2 pi, look at the unit circle. Your x value is 1. So that will be at 1. So that means your sine graph looks like this. And if you wanted to do another loop around the unit circle, it will just keep going like that. And also this way. Okay? So that is what the cosine function looks like. Now that we know what it looks like, let's answer the questions. Your amplitude, it's the distance from the midline, so this is the middle, to the top or to the bottom. So what's this distance? 1. And we completed one cosine function within 2 pi, so that is your period. Your domain is always the same, all real numbers. We did not move left or right, so we don't have a phase shift. What it means by phase shift, let me show you one. If we started here instead. Oh, if we started here, that's a phase shift. It shifted to the left pi over 2. We don't have a phase shift yet. We're going to cover that later. Okay. Your range is -1 to 1. You have 2 relative maximums. In one period, we have 2 maximums. There is one right here at 0, 1, and the other one is at 2 pi 1. Here and here. Here's your relative minimum. That is at pi -1. Now let's try some transformations. So you saw the parent functions. What are some transformations you're used to hearing about? Up, down, left, right, stretches, compresses. Exactly, reflections. So let's look at some. I have 2 sine x plus 1. Let's try that one. Exactly, you would say that's a vertical stretch by 2 and it went up 1. Exactly, that's what it is. So I'm going to write this out. Let's figure out what these are. Let's plug in sine for 0, or a 0 for the x. Sine of 0 is 0, so I'm just here at 1. Sine of 0 is 0. The unit circle, and then add 1, you're at 1. Sine of pi over 2. Do you guys remember what the sine is for pi over 2? Okay, so you guys need to draw a unit circle. Yes, you do. Draw a unit circle, because this needs to be automatic. 0, 1, -1, 0, 0, -1. So guys, here's pi over 2, here's pi, and this is 3 pi over 2. Yes. So guys, the sine at 1, or sine at pi over 2 is 1. So this part is just 1. Sine is always y. Okay, so this is 2 times 1 is 2, plus 1 is 3. So that means at pi over 2, we're all the way up here at 3. Okay? Next, at pi, what's sine of pi? 0. So that's all gone. It's just 1. Next is 3 pi over 2. What's sine at 3 pi over 2? Yes, at 3 pi over 2, it's -1. So this is just -1. 2 times -1, -2 plus 1, that's -1. That's right here. I'll just put a dot right there. And then at 2 pi, what's sine at 2 pi? 0. And then you get 1. All right, so guys, that means your whole sine looks like this. It still took 2 pi to draw the whole thing. Your domain is always the same. What is my amplitude? Here's the midline right here. That's the middle. Look, this is the middle of my picture. You see, this has a hump and this has a hump. This is a middle. Oh, right. Okay. So guys, look, here's some key things. Where my midline is determined by what number in my function. How it goes up or down determines your midline. Please write that down. Up or down tells you the midline. What tells you your amplitude? Exactly. So your amplitude is 2, because look, from your midline to the highest point, that's 2 spaces. Okay? We didn't go left or right. Your range, the bottom is at -1, and 1, 2, 3, +3. That's your range. Here's a maximum, and here's your minimum. Your relative maximum is at pi/2 and 3. And your relative minimum is down here at 3 pi/2 and -1. Those are your relative maximums and minimums. Is the range always going to be in brackets? Yes. Okay. Good question. Your range will always be in brackets. There's no asymptotes here. Okay. So what I wanted you guys to pick up from this is that this number in the front determines your amplitude, and this number in the back determines your midline. So you don't have to keep plugging it in to figure out what your graph looks like. For example, here's a fresh one. What if I said 4 sine x - 3? That means you're going to go down to 3. This is your midline. You'll start here. I'll say this is pi/2, pi, 3 pi/2, and 2 pi. And then you go as a height of 4. So I'm going to go up 4. 1, 2, 3, 4. It'll look like this. And you'll go down 4. Right here. And you'll go back up to your midline. So that's a quick way to graph it instead of plugging in values every single time. Okay? This is your amplitude, the 4. And this is your midline, -3. Another example. If I gave you, okay, let me give you cosine this time. Let's say 3 cosine x - 2. Here is your midline. Your amplitude is 3, but guys, remember, let me remind you of the parent function. Your parent function looked like this. It started up here, and then it went down and then back up. So for cosine, if you want to do the same quick method, you need to go up 3. That's your amplitude. 1, 2, 3. It's right here. From your midline, and you'll go like this. Doop, 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 doop. This is pi/2. This is pi. This is 3 pi/2. This is 2 pi. That's what it would look like. Your amplitude is 3. You still need to finish it in 2 pi. And your midline's at -2. Great. So I'm going to give you guys another transformation that I want you to check. All right, if you look up here on the board, guys, Luke did this perfectly. Our amplitude is 1/2, yes. We finished the graph in 2 pi. I'm just gonna add these little numbers right here. So he finished 1 cycle of cosine in 2 pi, so that's your period. If you guys put 2.5 here and 1.5 here, that is perfectly fine. This is 1.5, this is 1.5. Wait, your relative maximum here is at 2.5, so it should be 5/2. That's the only mistake. So this should be 2.5. So this is 2 pi, 2.5 is your maximum. And your relative minimum, pi 3/2. Yep. Okay, perfect. All right, guys, real quick. Today we learned, let me write this down for you. Okay, so for our transformations, we learned about A and D. Tomorrow, we're going to be talking about the letters B and C, the inside. Inside of the parentheses, we're going to be talking about how B and C affect the graph. Today, we just did A and D, and of course, sine can also be cosine. Okay, so that's what we looked at today. We'll finish the rest of the transformations tomorrow.